Hey guys, so today we're going to be finding out how to find limits of trigonometric functions, mainly sine, cos, and tan trigonometric functions. So without further ado, let's dive right in. So in order to solve these types of trigonometric problems involving limits, you first need to know a very important formula, which relates with sine. So it's essentially saying that the limit as x tends to 0, not infinity, of sine x over x is equal to 1. With this formula, you can solve a variety of trigonometric problems, but let's dive deeper into this formula. So this formula essentially also states that the limit as x tends to 0 of sine, let's say 5x, over 5x is also 1. This is because that's essentially saying we could say 5x is maybe alpha, so we can say 5x equals alpha. Then we can rewrite this as the limit x tends to 0 sine alpha over alpha. And alpha in here is essentially x in here, so we could just say this equals 1. Therefore, that's how we got the limit as x tends to 0 of sine 5x over 5x is equal to 1. But questions aren't going to be this easy, obviously. Let's dive into another question. Alright, so now for another example, let's say you have the limit of, actually let me write it over here. Let's say you have the limit as x tends to 0 of sine 3x over x. So how do we approach this? Well, we have to make use of our formula right here, and we know it's kind of in the form since we have an x in the denominator, we have a sine x in the numerator, but here it's 3x and here it's x. And from the last example that we saw that the limit of x tends to 0 of sine 5x over 5x is equal to 1. Now you can replace any number for 5. You can say 2x, or you can even say 3x. So now we essentially have to put this into something like this. Okay, you'll get it. So essentially this is saying that we can also rewrite it. We're going to keep the limit as the same. And now we're going to introduce a 3x here. So now that we have a 3x here, this is obviously not equal to this. But if we multiply this by 3, let's do that. These are brackets, by the way. If we multiply this by 3, we see that this is automatically equal to this because 3 and 3 will cancel out. You're just left with sine 3x over x, like over here. Now we can simply apply what we learned here and what we learned here. We know that this limit is equal to 1. And essentially 1 times 3 is simply just 3, so therefore, the limit of sine 3x over x is equal to 3. Now we have the limit as x tends to 0 of sine 2x over 3x. Exactly the same procedure. We're just going to write limit as x tends to 0. And we want to make this 2x, the denominator 2x, because we know that sine 2x over 2x is simply just 1. The limit of sine 2x over 2x is simply just 1 when x tends to 0. Now, we can just write it as sine 2x over 2x. This is definitely not equal to this. So what can we multiply with this to get this? Well, we can multiply 2/3. The 2 and the 2 cancel out, the 3 becomes here, and then we get 3 times x, which is 3x, and numerator stays the same. So now we can simply simplify this. This is essentially 1 times 2/3, that equals 2/3. So our limit is 2/3. Alright, now let's change things a little bit. So our next problem is limit as x tends to 0 of 2x over sine 3x. Now, here we see that the sine 3x is at the bottom, not at the numerator, and here it's in the denominator. And we see that 2x is in the numerator here, but in the formula it's in the denominator. Nonetheless, we can still use this to find the limit of this. So let's apply the same exact procedure. Let's say limit as x tends to 0, limit x tends to 0 of 3x sine 3x. The reason I'm making this 3x is because eventually it will cross out and become 1. You'll see. So this is obviously not equal to this, so what can we multiply with this so that it actually equals this? Well, you could multiply it with 2 over 3. Remember, the 3's and 3 cancel out. 2 times x is 2x, and the denominator stays exactly the same. So that's how we know it's equal. Now, let's forget about the constant for 1 second. We can see that it's 3x over sine 3x. Another way you could write this is 1 over sine 3x over 3x. And this is exactly the same as this. Now, you see what I've done here. I essentially flipped this and put this underneath 1. This looks a lot similar to this formula right here. So essentially, we know that this is equal to 1. And 1 over 1 is simply just 1, right? So we're going to do 1. Now this part is solved. And now let's bring back our constant. 1 times 2/3 is simply 2/3. And that is our final answer. So our next problem is involving tan. So limit x tends to 0 of tan 4x over x. So we can still apply this formula. So we would essentially, let's rewrite this. So this is essentially saying 1 over x times tan 4x. It's pretty straightforward. Then we'll keep the 1 over x the same. And tan 4x, we all know that's sine 4x over cos 4x. Okay, so now essentially what we can do, we can rewrite we can keep the 1 over x the same. And now you could do sine 4x over 4x times 4x. Because this and this will cancel out, then we get sine 4x. And of course, we can't forget about the cos 4x, so we do 1 over cos 4x. Now, this is essentially saying, well, we can cross out the x, so x and s cross out. This is just 1, as we saw from our formula over here. This is simply 1. 1 times 4, since this is 1 and we still have the 4 here, times 1 over cos part of 4x. This is 4 times, we know that cos 4x is, if we replace the limit 0, we see that cos 4 times 0, that's right here, cos 4 times 0, that's essentially cos of 0. And from the unit circle, over here, this is our angle. We know that cos is the x value, and that is 1. So that's essentially 1, 0. This is essentially equal to 1. 4 times 1 is just 4. So that is our answer. Now, this next problem is a bit more challenging, but we will go over it together. Now, the limit x tends to 0 of sine x over x plus sine x. Let's simplify this a little bit. We know that whatever we do to the numerator, we have to do to the denominator, whether it's adding, subtracting, multiplying, dividing, all those operations. So let's just divide it by x, the numerator and denominator by x. The reason we are dividing it by x is that the numerator, we know that it becomes 1, and this over here, we divide this by x and we divide this by x, and a part of the denominator also becomes 1. So that's essentially saying that the limit as x tends to 0 of this, let's write that, limit as x tends to 0 of sine x over x over limit as x tends to 0 of 1 plus limit as x tends to 0 of sine x over x. Now we can simplify this. We know this is equal to 1. We know that the limit of when x tends to 0 is simply just 1. 1. And we also know that the limit of sine x over x is also 1, hence our formula. Now, simplifying this, we simply get 1 over 2, we add these, and 1 over 2 is our final answer. So another problem we have on our hands is limit as x tends to 0 of sine 2x over sine 3x. Now this is a bit different than our formula, but nonetheless, of course, we can still apply it. So this, you can essentially write it the same thing, the limit as x tends to 0 of this same thing, we're just going to rewrite it, sine 2x over sine 3x. But now let's multiply it by 2 over 2 times 3 over 3 and times x. The reason I'm doing it is because I want to make this function somewhat in the forms of this, so I can easily replace it for 1. That is our main end goal. And if we multiply it with 2 over 2 times 3 over 3 times x over x, this is essentially 1 times 1 times 1, so that doesn't change the value, of course. So we can essentially, let's take away the sine 3x for a moment. Let's get 2x and 3x. Now if we do this, we can get sine 2x over 2x times 1 over sine 3x. And we can also get, we also have 2 over 1 times 3 over 3 times x over 1. Alright, so let's rewrite this again. Sine 2x over 2x. And now we see that if we put we have a 3 and we have a x. So now we can put 3x on the top, denominator stays the exact same. And we also have a 2, a 1, a 3, and a 1. And that's just 2/3 since they're all being multiplied. Now we start to see a relationship over here. We see that the limit as x tends to 0, this is essentially just 1. This is also just 1 as we saw from our previous problems. And this is 2/3. So the limit of this is essentially 2/3, and that is our answer. Alright, now for a really tricky problem. Limit x tends to 0 of sine x minus tan 2x over x. If you want to try and give this problem a go, please go ahead. But for those who honestly have no clue on what to do, I'm just going to tell you the solution right now. So now we see a relationship between the tan 2x. We can rewrite it as sine x minus sine 2x over cos 2x all over x. And remember, there's also limit x tends to 0. I'm not writing it since I think it's given that limit as x tends to 0. And now, essentially what we can do, let's expand both of these terms. So let's do sine x over x minus sine 2x over cos 2x times 1 over x. This is exactly the same thing. The x goes to this term and the x goes to this term. Alright, now that we have this, let's leave this the exact same. And we are subtracting that. Now what we can do, let's take sine 2x over x multiplied by 1 over cos 2x. And this is exactly the same, I just switched these two around. Now let's write this the same way. And now we already know how to deal with these types of limits. We can essentially do sine 2x over 2x times 2. The 2 and 2 will cancel out, so eventually you would just be left with this if you simplified it, and let's just leave this the way it is. Alright, so now essentially let's move this over here. Alright, so we know that the limit as x tends to 0 of this one is equal to 1. We can just write that is equal to 1. We know that this is also equal to 1. We could do minus 1 and times 2 And then we also know the limit of this is essentially 1 over cos of 0. And we know that the cos of 0 is 1, so times 1. And the reason I replace 0 in for x is because x is tending to 0. And now we get 1 minus 2, which is equal to negative 1, which is our answer. So our final problem of today's video would be limit x tends to 0 of tan x minus sin x over x cubed. If you want to try and attempt this problem, please give it a try. And if you have no idea where to start, I'm going to tell you the solution right now. Alright, so this is, it's not working. It's alright. Alright, this is also equal to the limit of tan x, which is essentially written as sin x over cos x minus sin x over x cubed. We can also rewrite this as sin x over cos x over x cubed minus sin x over x cubed. I just distributed this for each of the terms since there are 2 terms. I just wrote it like that. Next, this is essentially saying sin x over cos x times x times x times x. X cubed, I just wrote it as x times x times x 3 times. And cos x, it just goes down below. This will do the same. Let's expand the x. So we get x times x times x. Over here, we see that this is sin x over x multiplied by 1 over cos x times x squared. So that's cos x times x squared. This is x squared. And we also see that this is sin x over x. So let's just write that, sin x over x times 1 over x squared. Now we see that this is simply 1. Let's rewrite it here. Limit of this as x tends to 0 is 1, as you see here. Limit of x tends to 0 for, we can simplify this a bit more. Alright, so this is essentially 1 over cos x times x squared. That's essentially saying this. Alright, and now we have 1 over cos x. So let's replace x for 0. We get cos of 0, which is 1, so times 1 times 1 over x squared. Let us not put a 0 in here yet. You will see why. Minus, this is simply 1, and this is 1 over x squared. Now we get 1 over x squared times 1 over x squared. And minus, my bad, there's a minus. 1 over x squared minus 1 over x squared, which is equal to 0. So the reason I didn't replace 0 in here is that you would get 1 over 0, which is infinity, minus infinity, which is still infinity, which would be the wrong answer. So you should always try to not replace everything. Like, you don't want to replace 0 in for everything over here, otherwise we would not have gotten this answer of 0. Instead, simplify as much as you can, and if you see a relationship, meaning things are getting canceled out, then don't substitute a 0 in those terms, which is exactly what we did. We didn't substitute a term in 1 over x squared or 1 over x squared over here. And that gave us 0. Alright guys, that's it for this video. I hope all of these questions really tested your brain power, and I hope you guys are much more confident in learning about limits of trigonometric functions. And remember, you just need to remember one formula to solve all those problems and many more. Just limit x tends to 0 of sin x over x equals 1. Catch you guys next time.